Good evening, everyone. Welcome to Dome at Home. Happy Pride. It's June. We're getting into summertime. The temperature is really hot today, as you can tell. We're going to have clear, sunny skies for the next few days, and it's been a great day to be outside. My name is Scott Young. I'm the planetarium astronomer here, and I will be your host for this evening's program. We will be taking a look at what's up in the sky, the planets, the stars, and we will be focusing on next week's solar eclipse. Yes, there's a solar eclipse visible from Manitoba. Everywhere in the province will get a chance to see it. It is not the best solar eclipse. It's not a total solar eclipse. It's not like the one in 2017 that you could drive down to the central United States and see it and see the entire sun eclipsed. It's not like the one in 1979, the one that got me started as an astronomer. It's a partial eclipse from here. If you happen to live in the very north part of northwestern Ontario or the North Pole or Siberia, you can see a very rare kind of eclipse called a ring eclipse or an annular eclipse. We'll talk about that as we get into all the details. Let's see, we also have a couple of other things as part of the show today. We're coming up to summer solstice. It's only less than 3 weeks away. That means we have the longest daytimes and the shortest night times, which in general is not great for stargazing. I mean, it doesn't get dark until 11:30 almost, it seems. And before, 3 in the morning, it's already starting to brighten up. So we don't have all that many hours of darkness. It's harder to stay up late to see the stars. But we're going to see what we can do. There are a few things you can see early, and we'll go from there. With me, as always, is Mike, riding the airwaves there and keeping the chats in line and things like that. How you doing, Mike?
I'm surviving the heat as best as possible, but otherwise doing pretty good. Yourself?
Excellent. Yeah, not too bad. Yeah, the heat. I'm not a heat guy, I got to say. My favorite season is, autumn, where it's about 16 degrees. I can put a sweater on. That's my kind of weather. This 30 plus stuff is crazy.
Well, you described, being able to see that annular eclipse from like the North Pole, Siberia, and I'm thinking, yeah, that might actually not be such a bad place to be right now, honestly. So,
Exactly. Yeah, I know. Everyone else out there is like, "What are you guys crazy?" But to each their own. I'm not a big fan of winter necessarily either. I just, I'd like to not the extremes. Oh, we just got a question from Lou in the chat here in Zoom. When will we see Mike on camera? Well, you see, Mike is actually an artificial intelligence program. He doesn't actually exist. No, that's not true. He does exist. I'm not sure when we're going to see him on camera. We'll have to ask him about that. Um, Mike will be checking all the chats and things like that. Please throw any questions that you have in the chat. I can see the Zoom chat here directly, but Mike will marshal all the stuff in Facebook and YouTube, and we'll get all those. We'll get to all those in the Q&A session at the end of the show. Let's get right into our Skywatch segment and take a look at what we can see in the evening sky. So let's first of all get to, this is the sky tonight. The sun has set and the brightest stars have come out. It's 10 after 10. I'm showing the sky here. So way, way later. If you get out and you have a nice clear horizon, you'll get to see the planet Venus, the brilliant white star that is very low on the horizon, way over in the northwest. It sets an hour or so after the sun. And so if you don't catch it at the right time, you'll just not be able to see it, unfortunately. But it will be around for several months, so you'll have some time. Venus is a beautiful object to see, nice and bright. It's always up against these beautiful sunset colors, so it's a nice thing to see. In this view, there is in fact a second planet. We used to have Mercury in here. Mercury of a few weeks ago was visible. It's gone down below the horizon now, so it's not visible. If I zoom in here a bit, maybe we'll be able to see that other planet. Here we go. Sort of up and to the left of Venus, there's a kind of a crooked line of stars here. There's the bright one in the middle, then a fainter one on this side, and an even fainter one over here. Well, these two stars are Castor and Pollux, the two stars at the head of the Gemini twins. You can't see the other stars, but if I draw in the pictures, sort of becomes visible of what they look like. Right over here, though, this is Mars. It'll be really hard to see now. It is getting close enough to the sun, and it's far away, so it's faint. You're going to have a hard time seeing it probably without binoculars, but you may be able to catch it if you go out at just the right times. And when I say just the right times, I mean sort of down to the minute, because as we slowly advance here, there's a balance between the stars becoming bright enough to see, the sky becoming dark enough, and then the stars just getting too low. You see that Venus sets very, very soon. It's always in a bright sky. Mars, you might be able to catch round about 11 o'clock still, if you've got a nice, clear, flat horizon with no buildings. That's it for planets in the evening. We don't unfortunately have other bright planets in the evening, but there is lots of stuff to look at. Over in the
Scott,
west,
Michelle on Facebook was noticing that the twins look like they're trying to grab onto Mars.
Yeah, that's true. Hey, it's almost like they're reaching out and trying to catch the thing. Yeah,
Yeah.
that's good. It's amazing. I'm still amazed that we can see Mars at all after all this time, but it is slowly still moving upwards. And so at a certain point, I guess about next week, it'll be almost in a perfect line with these two. Tonight, it just happens to be perfectly aligned with that arm of, I guess that's Pollux. Yeah, that's Pollux. So this is Pollux's arm. Okay.
Yeah. And just maybe one more thing quickly, Scott, just because somebody on YouTube was asking, Jaden was asking, why does one of the twins have a longer leg?
Yeah, there's not a lot of anatomical correctness in the sky here. If we just back up just a little bit, you will see that basically you use whatever stars are there, right? And it turns out that there's a star right behind my head here. There's a star right down here that makes these two legs the perfect size. But then there are two bright stars down here as well that are part of the constellation officially. And so they just connect them. You're right. It looks like he's got like a long tentacle or something coming off of his heel. But there are a couple of bright stars there. And so when the stars are visible, it actually looks like that. So yeah, the constellation figures, as you'll recall, most of them don't look like what they're named after. Gemini's not too bad, and it's just that that odd leg. And I guess this one has got a short arm on this side. His brother's arm is way longer. So, all right, Leo the Lion, way up here now over in the west. We started talking about Leo months ago. It's sort of a springtime constellation. I always find that the spring constellations seem to go by really quickly. I think it's a combination of they start to become visible, in the spring, and throughout their entire time period, the nights are starting later. Daytime is lasting longer and longer and longer, and then daylight savings time kicks in, and we just only have, it seems, a few months to see them before they're already setting in the west. So I didn't get nearly as much spring constellation time in this year at all. High overhead, we have, close to overhead is Arcturus and the ice cream cone of Borealis. This is a pretty prominent constellation at this time of the year. It's up nice and high in the evening. If you recall, it's very close to the Big Dipper. There's our Big Dipper over here. And the Big Dipper's handle, you follow the arc to Arcturus. That's how you remember how to find that particular star group. It is sort of one of the dominant ones at this time of the year, high up in the south. So it's a good one to watch for. Rising over in the east, we have the summer triangle. And I just realized here, I'm going to make a little setting change to my sky. When you project a really wide view of things, it gets kind of distorted because we're taking basically the round dome of a planetarium or the real sky and then putting it onto a flat screen. And I find it makes all the constellations look funny unless you set it like this. And that's where we get this rounded horizon that you're probably more familiar with from previous shows. So there we go. Here we have our summer triangle. We talked about this in detail last week. Nice bright stars coming up. And again, Hercules, one of my favorite constellations, doesn't look like much of anything. But that's the I've gotten to know this group of 4 stars here. It kind of looks like a waste paper basket with the open end up here. So that part's easy to see. In between Hercules and Arcturus, there's this lovely little circlet of stars. It's called Corona Borealis. It's the northern crown, and it actually is, it actually is pretty nice to see. Binoculars basically take that entire area and show them all at once. So that's a nice little thing to look for if you're out with your binoculars. And I think we talked about in Hercules, there's a star cluster right in on the right side of the waste paper basket here, about a third of the way from the top to the bottom, right down in here. We have a beautiful star cluster called the Hercules star cluster. And that's another great target for binoculars. Okay, you know, we look over to the north and it's still sunrise. I mean, here I'm showing the sky like 20 after 10 and it's still bright there. Let's jump forward. Oh, that wasn't the right one. There we go. So here's the sky at 20 after, and it's finally got kind of dark, although you can still see some twilight glow along the northern horizon there. In the north, there's our Big Dippers. Oh, I got to pull it down for you here. There's our Big Dipper, has swung way over into the northwest, the handle up at the top now. The 2 pointer stars in the bowl always pointing back to the North Star over here. And that gives us our view of the northern part of the sky. Let's just get this set here. High overhead at this time, really you've still got the Big Dipper is up pretty high, and then Arcturus over there. I know it's flipped around here. Let me flip it around. There we go. So you're looking at the Big Dipper, the Arcturus, and then Boetes, the herdsman, is basically the center part of that part of the sky. All right. Now we will come back to the morning sky a little bit later, but I want to get into the other portions of the show here. I wanted to take a look at a couple of, someone was saying, Wesley was saying, Boetes looks like a tie. Yeah, it totally does. One of those really wide ties that you give your dad on Father's Day or whatever. Yeah, that's my thinking as well.
Scott, maybe you can also get Grayson's question there about, can a planet be a part of a constellation? Because it does.
Oh yeah, that's a great question. So Grayson, the planets are not officially parts of constellations because they're always moving. And so what happens is, if you were to put it into the picture, you know, that particular dot would move night after night and go into a different constellation. So they don't make planets part of a constellation officially, but those planets do move through constellations. Like, for example, when we were looking at, we can still see it here. When we're looking at Gemini, come here, there we go. We've got Castor and Pollux, and then we've got Mars over here. So Mars right now is in the constellation of Gemini, and it'll slowly move off until it gets into the constellation of Cancer, the crab, which is up over here. The planets move through those zodiac constellations, the ones they use for horoscopes and stuff like that. That's how those constellations got picked for horoscopes, because the planets and the moon and the sun all move through them over the course as they orbit around the sun. And so you'll never see a planet in the Big Dipper or in Orion's belt or anything like that. They only go through those 12, 13 constellations of the zodiac. And so even though they aren't officially part of the constellation, you can still see them in certain constellations as the year goes on. All right, let's see. We got, I actually didn't get a chance to see all of the mail that we had this week around. Had a number of different things. I did see that we got some pictures in. I saw something from Ulrich. Thank you very much. Well, I tried sending you an email, and apparently I just sent it back to the museum. So I'll drop you a line later on after this, and we can chat a bit. It was a great little picture. And people keep calling my phone. All right. Coming up, we always try and look ahead at what's going on in the sky. And Manitoba Museum's website is updated for June. We have in the planetarium section, there's the Manitoba skies column, the current night sky, and it lists all the things that are happening in the month of June, you know, when the full moon is and all that kind of stuff. Well, coming up on the morning of the 10th, we have a partial solar eclipse. Mike's dropped the link into our chats there so you can see all of the things that are going on. We've got an article in there on how to observe the solar eclipse safely. We're going to go over some things in that right now. And I do have to say that the eclipse is one of those things that is pretty cool to see, but it's not the kind of eclipse that you should, you know, sell your house to buy a vehicle to go drive to the right spot kind of thing. It's not a total eclipse. It is a partial eclipse. And so from here, it's an interesting thing to watch. Unfortunately, it happens at sunrise, 5:20 in the morning or so for southern Manitoba, even earlier for the folks up north. So let's take a look at the solar eclipse and figure out exactly what we can see. And then we'll talk a little bit about how you can safely view it. Because of course, as most people know, you should never look at the sun with any kind of optical aid or anything like that. Having a view of the sun has to be done safely or you can really hurt your eyes. This is a picture I took back in 2017. I did drive down to Nebraska with my family to go see the total solar eclipse there. And this was taken in the early part of the eclipse where the moon is just moving in front of the sun. And that's basically what happens during an eclipse. We've got the moon orbiting around the Earth. We've got the Earth orbiting around the sun, and they line up. They usually don't line up exactly, but when things line up exactly, you can get the moon right in our view from the sun. It moves right in front of it, blocks it out. And by an amazing coincidence, the moon is about 400 times closer than the sun, but the sun is 400 times bigger than the moon. And so that the two of that basically cancels out and they appear almost exactly the same size in our sky. So when the moon covers the sun, it just covers the bright part of the sun, the normal yellow part that we can see, and it reveals the sun's corona, the outer atmosphere, which is this blue, ghostly kind of thing. That isn't happening this month. But Manitobans can see a partial eclipse where the moon will cover part of the sun. And our best view from here in southern Manitoba will be about like this, the moon roughly covering half of the sun's diameter. Now, like I say, it does happen quite early. So let's take a look at what's happening. Here's an image from NASA that basically describes sort of the coordinates and a whole bunch of details. Ignore all the numbers, I do. Basically what I use this for is the map. You can see North America down over here. There's us in Manitoba right there. And then this path along here, that's the path where the eclipse would be as close to total as is possible this time. We'll talk about that in a minute. But basically this is where, if you stood there, the moon is blocking out almost all of the sun. So that goes from northern northwest Ontario, like north of Thunder Bay and way north up to Hudson's Bay, all the way up through the North Pole, and then down on the other side of the Earth into very eastern parts of Russia, and then disappears. Now, of course, over here, you can't see the eclipse because it's dark. The sun is below the horizon. And you'll notice that we're right on the edge of the dark and the bright. The eclipse for us is already started by the time the sun has risen. So that's part of the thing. You know, this view that we have here, if the Earth wasn't in the way, we'd actually see more of the eclipse. But unfortunately, that's not the case. So this is kind of the map. Now, originally, I had thought, hey, you know, northwestern Ontario is not that far away. It'd be cool to see a ring eclipse, an annular eclipse. We'll take a drive. Well, that obviously isn't happening. And I'm not aware of anybody in the Ontario area that is going to be able to necessarily do a live broadcast of this. However, I'm sure there will be people out there. And so hopefully we'll get some pictures back. this is what you're going to see sunrise on the 10th from areas around Winnipeg. The moon is this dark part. We can't see, we're only seeing the dark part, of course, because the bright part is facing directly away from us towards the sun. And the sun will be this kind of strange hook-shaped thing rising. Now ignore this. These are just sunspots that are drawn on the picture by the software. They're not necessarily really there. So, but you'll see the sun rising like this, and it'll probably be like a regular sunrise, sort of reddish color. It'll probably be a little ominous, actually. And then by the time the sun actually starts getting up high enough for you to see well, the moon is already moving off. The moon is moving to the left in this picture, essentially. And so, you know, by about 6 in the morning, the moon has moved almost completely off the sun. And look, the sun is not very high up in the sky, and the eclipse is already over. So for here in Manitoba, in southern Manitoba, pardon me, not the best circumstances. There are other places in Manitoba, though, that will have better luck. In fact, it turns out as you go farther north, more and more of the sun will be covered. So we've got some viewers up in Thompson. We've got folks up in Churchill that watch the show, and they're going to see a sunrise that looks like this, just a typical regular sunrise. But then by the time the eclipse starts after sunrise, they'll be able to see the whole thing. And as the sun rises, they'll wind up with about an 85% eclipse. It is a great view for folks in northern Manitoba. So if you're already up there, that's definitely the place to be to get a better view. Still, 85% is not exactly the same as a total eclipse. Now, this time around, there is no total eclipse. There's nowhere on the earth that you can stand to get a total eclipse. And the reason is the moon is too small. Here's the view from the center line. And you get that ring, or an annulus, and that's why this is called an annular eclipse. It's basically the moon is slightly too small to cover up the sun. Well, how can that be? Well, think about the supermoon. Remember that we always talk about supermoons and how the moon is a little bit closer and a little bit farther away? Well, when the moon is at its closest point during full moon, they call it a supermoon. Well, it turns out that the moon is at its farthest point right during this eclipse. And so the moon looks a little bit too small compared to the size of the sun, and you get this ring eclipse. So still kind of interesting, not nearly as spectacular as a total solar eclipse. We'll probably have to wait for 2024, which is the next good one that crosses North America. That's it's already time to start making plans and thinking about that, taking a drive and so on. Mike has posted a great eclipse site in the sky there. Melissa was asking about places that are in the midnight sun, where you're in full sun at this time of the year. Would they see this phenomenon? Yeah, actually, if we go back to our map here, there's still a geographic limitation, but you'll see that all the folks that are in this area, oh, can you see my pointer? Yeah, basically in this area here that are in the midnight sun will get to see the eclipse. Most of them will get to see a partial eclipse because the annular eclipse only happens in this narrow band here. But still, the folks up far north will have a great view. Now, I know that there are some great photographers up there in Churchill, so I'm counting on them. Ashley, if you're listening, I'm counting on you to get some great shots of this. There's also a webcam that you can get to from explore.org, which will, normally it does the northern lights, but it may also be doing some eclipse things. If we can find some live stream eclipse stuff, we'll get those posted on the museum's page in the days leading up to the eclipse. I do plan to get up early, and I've got the alarm set for 4 that morning so that I can get out to a nice site with a good flat horizon and stand there and hope that it's clear so that I can see the partially eclipsed sunrise. It turns out that this is exactly a week from now, and so it's the morning before our next Dome and Home show. So hopefully we'll have some great pictures of the eclipse next week around for Dome at Home. Let me just see here. Here's the thing about the eclipse. You cannot look at it without damaging your eyes. It's not anything special about the eclipse. The sun is always too bright to look at. It doesn't matter if you've got sunglasses on or whatever. You know, if you look at the sun for too long, you can permanently damage your eyes. And certainly if you were to use something like binoculars or a telescope to look at the sun, you would instantly blind yourself. You would completely destroy your vision permanently, irrevocably. Never look at the sun unless you have a certified safe solar filter. Now, there's a couple of ways to do that. Back in 2017, the museum was selling these eclipse glasses, which are incredibly stylish, and you can't see anything at all through them except the sun. This filter material is dark enough and dense enough, and it blocks out the invisible infrared and ultraviolet rays. It's not just a pair of sunglasses that are really dark. It's actually a special certified solar filter. If you still have these kicking around from 2017, just make sure there's no holes in them, you know, in the black film. These will help you observe the eclipse. If you don't have that, there is a couple of ways to do things. You can make a pinhole camera, which I've seen a few sites online, or you can use a pair of binoculars. I made this set of binocular projectors, and you do not look through these binoculars at the sun because there's no solar filter on the front. You use these to project an image of the sun. I'll show you what I did. Started off with my binoculars and a piece of cardboard, and basically you trace the two lenses onto the piece of cardboard, and so you wind up with these two circles. You cut out the circles, and so if you're a younger viewer, make sure you get your guardian to give you a hand with this. This is the part where I cut my finger because I was not being careful, jabbing the scissors through the cardboard. You wind up with a piece of cardboard with two binocular-sized holes in it, which fit right over the front of your binoculars, which is a good start. The next thing you do is you take one of the lens caps and stick it on. We only need one lens. You only need half the binoculars, really. And so putting the lens cap on the other one, it keeps the cardboard in place, and it also gives you, you know, security that you're not going to accidentally have light come through when you weren't expecting it. So you wind up with this pair of binoculars. Now, you do not look through the binoculars. You hold them in front of you. The sun is behind you, and you hold them in front of you like this, so that the lenses, the eye lenses, are pointing down towards a little white piece of paper that you stick there. And I just propped up a piece of paper up against a little suitcase here. You had to sort of fiddle around to get the angle right. Ideally, this piece of paper and this piece of paper would be parallel to each other. My sun image looks a little bit oval shaped because of that, a little bit distorted. But you wind up getting an image through the lens of the binocular projected onto the piece of paper. You focus the binoculars until the edge of the sun becomes sharp and crisp. It'll look sort of fuzzy and blurry, and then as you focus, it'll shrink down and get down and down, and then it'll be nice and crisp, and you wind up with an image of the sun. So this is, I just did this today, shot these pictures today with my ordinary household pair of binoculars. It was kind of hard to hold the binoculars steady, I will admit. So it would be even better if you had a tripod for your binoculars. But if not, you just have to get to a comfortable position where you can hold the binoculars nice and steady so that they're pointing over your shoulder at the sun. And then maybe a friend or someone else had the piece of paper at the bottom. Now, when you look at the sun, when I took this picture, there's a little spot right there. And I assumed at first that this was a little spot that was just a piece of dust on my binocular lens. But then after I got inside, I didn't even notice it when I was taking the image, because I was doing all of this and then also taking a selfie. So it was a lot of things going on. But got inside, saw this little dot. I thought, I wonder. So I went and looked at the situation of the sun. That was a sunspot. So this system can show sunspots. with just a regular pair of binoculars. It's in exactly the same spot, so that's got to be it. So this is what the sun looks like right now. One fairly good-sized sunspot. There's a few more starting just over there. Maybe by the time eclipse stuff comes on, we'll have more sunspots. These ones will slowly move this way over the course of the week or so. So they might be gone by the time the eclipse is on. But that was kind of cool. I was impressed that I was able to see the sunspots. When you do this during an eclipse, you'll see this. Basically, you'll see the moon taking the bite out of the sun, and so it'll work really well. Now, Lorraine just asked if we have any eclipse glasses available. We do not have any eclipse glasses from 2017 available, and with COVID and everything like that, we just, our shop is not open. We just weren't able to get any kind of supplies. So basically, unfortunately, we don't have new eclipse glasses that you can get. There are a couple of options that we talk about in the article on our website, though, and you can check that out. And Charity was asking, when you look at the paper, wouldn't that be a left-right mirror image of how it is looking through the binoculars, because the papers are a reflection? Yes, I forget if it's left. Actually, it's not left-right. It's, the whole thing is rotated around 90 degrees. And there will be the reflection. So actually, there'll be two. It'll be upside down and left to right reflected. But when it comes down to it, there's no real up or down in space. And so when you're looking at the sun, it'll be pretty clear to see sort of which, where the moon's coming from and so on. So this is a great way to look at the sun, totally safe. The only thing that I recommend is that you don't do this continuously. The heat builds up inside your binoculars. And so I was doing this for like a minute, and then I pointed them away from the sun and let them cool down a little bit. That might be a little excessive, but I just didn't want to have it melt any of the stuff inside the binoculars, because the energy here is crazy. I've held binoculars up to the sun and put a piece of paper here, and you set the paper on fire. So this piece of paper needs to be far enough away that it's not focused to a very, very large or a very, very small point. So if you look back at my image here, this is a couple of feet, maybe up to a meter or so. And the bigger that this distance is, the bigger your image of the sun will be, but also the hardest it will be, the harder it will be to keep it centered, because you really have to keep it angled there. Now, there have been a few things come through the chat about different potential filters and things like that. I have to say, there's two parts that any filter has to do. It has to block out the visible light. That's the stuff that your eyes can see, but it also has to block out the invisible stuff, the infrared, the ultraviolet, and that's not something that you can tell. Your eyes will tell you if the visible light is too bright, because it will be, it will feel too bright, but your eyes cannot even notice if there's infrared or ultraviolet going into your eyes and causing damage. So we don't recommend any kind of sort of homemade filters. I've heard a number of things over the years, everything from smoked glass to old photographic film, CDs, electrical tape, those Mylar reflective balloons. All of those will dim the visible light to some degree, but they will allow all the other stuff right through and damage your eyes. So definitely do not worry or try to make your own filters or things like that. If you don't have binoculars, there is a way to do this with just a cardboard box. You don't even need lenses. And that information is part of our article on the website as well. So you can check that and should be able to see, find a way to see the eclipse. Let's just get to the end here. I was just impressed that I was able to see the sunspot with this little set of binoculars, so that's pretty cool. If you have a telescope, the filter that you use has to go over the front of the telescope. It's going to look like a mirror because it reflects 99.99% of all the light. And the solar filter probably cost $100. If you didn't pay $100 or more for your solar telescope or your solar filter, you might want to drop me an email before you trust it trust your eyes to it and use it. And certainly any filter that fits at the eyepiece end down at the bottom, it's too late at that point. Your giant magnifying lens has already grabbed all this light and focused it down to a little point. Putting a filter there isn't going to do anything. In fact, all that's going to happen is the glass filter is going to overheat and shatter and let sunlight and pieces of glass into your eye. So you really don't want to mess around when you're talking about your vision. Let's see. So that's the way. I'm going to be using my binoculars to see the sun with that projection method, and I'm also going to have the video camera set up to take a variety of images through the telescope. So I hope that works out. The weather forecast this far out, who knows, a whole week away, but hopefully we'll get some clear skies. We would love to see and hear any stories of your eclipse trips, wherever you go here in the province, whether it's just in your backyard or you go, to a different place. I'd love to see your pictures and hear the stories of what it's like to see the eclipse. So make sure you drop us a line, send us your pictures, send us your stories, and we'd love to talk about them next week on the show. All right. I think we're getting close to question time here. Let me just see if we have something else I wanted to show here. We went through all of these, and let's see. We have, oh, look, there's George. George came out with me today while I was doing all the solar observing, and he was quite happy to sit there in the shade while we were chatting. So there's your George picture. I know he gets more requests than Mike and I do, so it's something I want to make sure I deliver on for the fans. Okay, Mike, what do we have for questions out there?
You caught me by surprise. Sorry, I've been responding to lots of questions. There's lots of discussion about proper viewing of the sun and the eclipse. Nicholas on YouTube was asking, sorry, I might have missed this if you actually touched on it, Scott, was asking, can they wear a welding helmet to view the solar eclipse?
Right, yeah. If you have a welding helmet that has number 14 filter in it, then yes. If it's less than number 14, it still allows too much light in. Now I know the way welding filters work, you can stack them, and so a number 12 and a number 2, for example, will give you the right density as well. But that's something, if you're a welder, you'll know how that works. Welding supply stores in Winnipeg will probably have a piece of welder's glass like 3 by 5 inches. I think I paid $20 for mine last several eclipses back, and I've had it ever since. And it's a much higher quality image than the flexible eclipse glasses, just because this is a crinkly kind of thin plastic as opposed to a nice optical glass. So that's a great choice. Yeah.
Oh, I lost my question. Oh, shoot. Let's jump to Ulrich's question that she just asked on Zoom there. When using magnifying glasses, will it not heat up so much?
Yeah, it's interesting. With a magnifying glass, you actually only have half of the lenses that you need. The front lens of a pair of binoculars collects and focuses the light to a point, but you need a second lens at the eyepiece end to then sort of spread it back out into the proper things and focus it so that your eye can see the image. I think you could take 2 magnifying lenses. That's basically all a telescope is 2 magnifying glasses of certain focal lengths and have them in a row, but I'm not sure that you'd be able to get the full image. Now, you know what? I haven't tried it. So I think if you just use a magnifying lens, all you can do is focus down to a point, but I'm not sure you can form an image that would show the moon. But it would get rid of all the heat problem for sure. And
oh, sorry, were you done with it? Okay, I would just remember what I was going to say. I did a search for live stream of the annular solar eclipse. There are some sites that are claiming they're going to do that. It wasn't clear if they actually had a site that was directly under the actual annular, or whether they
Yeah.
were doing a partial one. So folks, if you're out there doing a search for one, there's that caveat that it may just be another partial view. Admittedly, this is going to be a really tough eclipse. I mean, even in non-COVID times, it would be difficult to get to some of the locations of this annular eclipse. So I have no doubt that during COVID times, it's going to be that the challenges are going to be even more. So, yeah.
It will be a tough one for sure.
Yeah, for sure. Maybe we'll flip to some questions that have nothing to do with tonight's topics. There's been some good questions coming in about that. Melissa was asking, any thoughts on the recent discovery of glaciers on Mars? We're missing out on some cool space stuff here.
Yes. Okay.
Cool space stuff.
I knew that'd be a good segue.
Yeah, I just love Mike's voice on that. In case you didn't know, that's our very own Mike doing the voiceover there. Yeah, the Mars glacier discovery it's kind of something we expected. You would expect that on a planet that has water somewhere and that has ice caps, that glaciers wouldn't be out of the question. But it was kind of weird that we hadn't already found them. This is the kind of thing that I forget which spacecraft data this came from, but it didn't come from Percy and Ginny that are there now. It came from old data from spacecraft like 10 years ago that they've just finally gotten around to doing all the analysis and all the science on. So it's amazing that, we kind of get excited about the current pictures and the newest thing, but a lot of the science, a lot of the discoveries actually comes from people sifting through that information over and over and over again. And that's really where this kind of stuff came from. So that's pretty cool. The idea that there are these big reservoirs of ice that are solid, that basically means that there's a lot of resource that if we ever go to Mars with people, we've got access to. So that's one more piece of the puzzle in terms of getting humans to Mars.
Any other cool space stuff, or you just decided to throw in the tag there?
Yeah, I just threw the tag in mostly because, the eclipse one, because we wanted to talk about safety and we wanted to cover how to make these projectors and things like that. We sort of didn't have a whole lot of time for that. And actually, there wasn't a new flight from Ginny. There wasn't sort of a big thing other than the Mars Glacier, which just came out yesterday, I forgot. Vivian's asking about, hi Vivian, the moon missions of NASA and the Chinese and Russians, where they plan to send humans to the moon or space bases or things like that. It's kind of interesting. There's a lot of interest in going to the polar regions of the moon, because we think that in the polar regions, there could be craters that just don't get any sunlight. And in those craters, there could be ice. Or there could be ice just under the surface. The temperatures would be sufficient for that. And so that's an exciting thing, because again, if you don't have to bring all of your oxygen and hydrogen with you, but you can just dig it out of the ground in the form of water, that makes exploration a whole lot easier. So I know that the recently announced Canadian moon rover is planned to go to a site near the South Pole, not right at the South Pole, because then you run into problems being able to communicate with the Earth and so on. But close enough to the South Pole that it'll do some good research around there. So that'll be interesting. The Chinese and the Russians have talked about their plans to go to the moon. I'm not as familiar with the details, partly because they tend to keep changing. And certainly the Chinese program is very tight-lipped about what they plan to do in detail. They'll say, we're going to send people to the moon, we're going to build a base on the moon, but they probably won't tell us anything else about it until they do it. That's sort of the way that the Chinese space program tends to operate, as opposed to NASA that basically gives you a live feed to everything and lets you ride along. So it's kind of a different approach. What else do we have, Mike? We got time for a couple more, I think.
Yeah, Ben was just asking for clarification on the Mars glaciers. Are they water or are they frozen CO2?
That is a great question.
I'm thinking they're water. I think I read that they were water.
Yeah, I'm pretty sure that they're water, but there was some, like there was some carbon dioxide involved, but it was a pretty small percentage. So.
Terry is on Facebook, one of our, of course, longtime viewers on Facebook.
Hi, Terry.
Mentioning about the 2 new robotic missions to Venus that were just announced.
Yes, right. We could have done that for. I was so focused on the eclipse and making sure people could see that safely that I kind of dropped the ball. We'll have to do double cool space stuff next time around. 2 robot missions to Venus. You might remember about a year ago, scientists announced that they had discovered chemicals in the atmosphere of Venus that on Earth can only be made either in a lab or by biology, by living creatures. And they're pretty sure that no one has a lab on Venus making this stuff. So the thought was there could be life floating in the clouds of Venus. That's kind of crazy. Venus has got clouds of acid. The temperature is the hottest of all the planets. It's a nasty place. But in the clouds, there might be this sort of Goldilocks zone where it's not too hot, not too cold, and so on. Well, that sparked a lot of interest. And I mean, we've been exploring Mars every couple of years for decades. We have not sent anything to Venus in 30 years. And the main reason is every time we send something to Venus, it lasts an hour or 2 before finally being destroyed by the temperature and the pressure and the acid clouds. Like it's not an easy place to explore. So they've announced 2 spacecraft. One is going to be an atmospheric probe that will go in and basically look at the atmosphere and do analysis and things like that. And the other one will be an orbiter that will do stuff from orbit. And it's pretty exciting to be going back to another planet. I mean, I love Mars. Don't get me wrong, but I mean, red rocks. I want to see something different. It'd be nice to see the modern technology applied to a different planet, because really, I mean, if you think about it, the last time we went to Venus, digital cameras weren't even a thing. There was no image processing other than, the guy in the lab letting it sit in the chemicals longer a little bit. Like it's such a huge change. I mean, that's a bit of an exaggeration, but it's such a huge change. I'd really love to see what modern technology can do on Venus. So that's going to be really, really exciting.
And maybe just to quickly wrap things up, Felicia on Zoom was asking about a bright star to the right of where you started on the constellation map. I'm not too sure.
Yeah, I know exactly what you're talking about, and it is a star that I keep seeing it and thinking, oh, is that Venus? No, it's not. It's this star over here. Let me get you to the star map here. It's this star over here. It's called Capella. Capella is a very bright star. It's in the constellation of Auriga, and at this time of the year, it is basically in the sunset area. So there's Venus. This is where we started. Capella's to the upper right there. And Capella never quite sets. It actually just loops along underneath, kind of like the Big Dipper does, and just gets down low in the north and then comes up again over in the eastern side. So it's often visible very low on the horizon if you're looking north. And because you're looking through all of the air and all of the turbulence and the heat from the city and all that kind of stuff, it often flashes different colors, red and blue and green. That's not the star doing that. It's our atmosphere breaking up the light, breaking it up into the rainbow of colors and sort of distorting it and twinkling it all over the place. But yeah, this is a perfect time of the year to see that. Yeah, that's the one. Okay, good. So I got the right one. It's often reported at this time of the year, hey, what is that? Is it a planet? Is it the space station? Is it aliens? That kind of stuff. But it's a star, and it just happens to be in a point where we can get a really kind of a cool, colorful view of it.
And Scott, can you maybe wrap up and promote our binocular course that's coming up in a week or so?
That's right. Since telescopes have been so hard to get to, we are looking at doing a lot of binocular astronomy recently. I've pulled my binoculars out quite a bit recently. And so we're doing a course. There's one on June the 13th, which is Sunday. And then there's one on June the 15th, which is a Tuesday evening. And both of those, it's the same course, so you can take whichever one sort of works for you. And we're going to go through how to choose binoculars for astronomy, what kinds of things you can see. We'll talk about star maps. We'll talk about the different kinds of objects and and how to observe and things like that. Basically a general binocular observing course. It's a 2-hour program, and you can sign up and get your tickets through the Manitoba Museum website. And Mike has dropped the link there into the chat. Pietra, hey, how's it going? Asked if there's preemptive binocular recommendation. You know, if you already have binoculars, those are the best ones. I had a pair of 7x35 binoculars as a kid that my dad had that I just started using because I didn't know that they weren't supposed to be the best kind. And I did a lot of great stuff with them. So I think in this modern world, we tend to hang up on the details of the gear and all that kind of stuff. If you have a tool, it can work. If you have binoculars, if you have a telescope, any kind of optical stuff, even if you have one of those little spotting scopes or opera glasses, surprisingly enough, anything like that, try it on the sky, not the sun, but try it on the moon or the planets, or just look around in the stars, and that will get you started. When we get into our course, we talk not only about sort of what kind of gear, but also how to best use it. Things like how to get your eyes as sensitive as possible, all those kinds of things. So there's a whole bunch of tricks that we can share that will make your observing a little bit more productive and successful, hopefully. All right, went a little long today, but there were lots of great questions. It's always great to hang out with all you folks. Thank you so much for joining us. We will be back next week, and we will hopefully have a debrief of the eclipse, some great pictures from the past, from the event that morning, and we will also be announcing our summer plans for Dome at Home. So make sure you tune in for that. As always, you can reach us in between shows. We've got Facebook, YouTube, and our email space at manitobamuseum.ca. And you can always catch us on social media. I'm Scott the Skywatcher on Facebook, and you can drop me a line there. On behalf of myself and Mike and George the Cat, thanks for joining us. Enjoy the warm weather if you have it there. Get ready for the eclipse and have some clear skies, and we'll see you again next week. Thanks for coming.